All right. Two ideas that we didn't get to cover in the unit because they're not particularly important to the unit, but they do appear on the regions from time to time. So I figured a video lesson would be appropriate. So idea one is how many common tangents can we draw to two different circles? So what that means is, so for example, this is a tangent line to the rightmost circle. If I move it over a little bit, that's a tangent line. But notice it's not tangent to the other circle. It's only tangent to the one circle. So I'm looking for lines that are tangent to both circles. So this is really just a thing where you have to think about what you could draw. So I want you to pause the video, and I want you to try to draw at least one tangent line that's common between both circles. So please do that. All right, hopefully you paused the video and you drew a tangent line. Now, I don't know the tangent line that's common between the two circles. Now, I don't know which one you drew, but here's one that I could draw. Something that looks like this. I'm a little off at the end there. It's not easy to do all the time. So let me redraw that. It's not easy to do, like I said, especially on a smartboard. It's actually probably harder to do. That's not bad. So there's one common tangent line. So far I have one. Well, I could do the same thing on the top to the bottom here. Oops. See? I'm not very good at this, but here's another one. There's two common tangents. Now, you got to get creative for some others. There are two more. There's one here in the middle. I can go boop, boop. There's three. And then I can go diagonally the other way. And there's four. So, well, that one didn't come out as well as the other ones. Hold on, let me redraw that one. Cut that out. I'll redraw this one. Sometimes it's easier if you make points for yourself. That's not bad. So actually, and there are no more you can draw, because if you try to draw a tangent to one, it won't be tangent to the other circle. So when the two circles don't touch and they're well away from each other, you can actually draw four common tangents. All right? Armed with that example, you should go through and try the other cases. So for example, case 2 is where the circles touch each other once from the outside. The circles themselves kiss each other. Mwah, right there. Number 3 says the circles touch each other twice. They kind of intersect like a Venn diagram. Case 4 is where the circles touch each other only once from the inside. So one circle's kind of inside the other, and they touch each other once. I know it doesn't look like it, but the circles only touch each other at that one point. And number 5 is when one circle is completely inside the other. So I would suggest pausing the video and trying to draw as many common tangents as you can. All right, hopefully you pause the video to draw as many common tangents as you can for each situation. I'm going to go through them now. So can't really tell if you paused it, but you should have. So circles that touch each other once from the outside, well, kind of like this scenario, kind of like the first scenario, I have the two blue guys that I can draw. So I have one, I'm off a little bit, but one, and then two, okay? And then, because the circles touch each other only once, I can draw a third tangent that touches at that spot as well, but I can't draw that fourth tangent that we could in the first case. So there were only 3 common tangents for this situation. All right, next situation is where we have the circles touch each other twice. Whoops, didn't mean to do that. Hold on a second. Okay, let's try this again. Perfect. Okay, so circles touch each other twice. Well, I could still draw the blue guys, those blue tangent lines. Something like this. I'll try to connect these 2 points. There we go. And I'll try to connect, say, these 2 points. You can draw that. And guess what? That's it. Because if I try to draw the line down the middle again, that's a secant line to both of those circles. It's stabbing both of those circles. It's not kissing or touching once. So that's got to go. That's not a common tangent line. So in this situation, there are only two common tangents. The next situation is where the circles touch each other once from the outside. They touch each other at this one spot here. And guess what? I can clearly draw that tangent line. Okay? But any other tangent line is going to not be tangent to the other. So, for example, if I try to draw this tangent line, it's going to stab the other circle. It's not going to be tangent to it. Similarly, if I try to draw a tangent to the big circle, it's going to be outside of the picture, so it's never going to intersect the little circle. So, there's only one common tangent in this situation. And case number 5 is when the one circle is completely inside the other. In which case, any tangent to the outside circle is never going to intersect the smaller circle. And any tangent inside the circle, any tangent to the little circle is going to intersect the big one twice. So there will be no common tangents in this situation. And that's really it. I think once you get the hang of it, it's just kind of common sense and you just figure it out. All right, idea number 2 is different. Has really nothing to do with idea number 1. It says, how can you determine which chord is largest? And I said, in question 1, I said, what is the largest chord you can draw inside circle O below? So I would like you to try to come up with the largest chord that you could draw inside that circle. And there are many largest chords. They're all the same. So pause the video and try to come up with the largest chord you can draw inside that circle. Okay, so hopefully you realize the largest chord you can draw is any diameter. Any diameter that passes through the center is the largest chord. So I can draw many largest chords, but they're all diameters, which means that they're going through the center, which means all the diameters are 0 in terms of distance. Let me write this a little differently. Diameters are the largest chords, and they go through the center. Okay? Now, what happens if I take a diameter? So let's say I just have my diameter, right? And now I want to move my chord away from the center. So this chord, this blue chord, is a diameter, goes through the center. But let's say I start moving my chords away from the center. So here's a chord. Notice it's a little bit shorter than the blue. It's just a little bit shorter if I compare them side by side. And then if I keep moving away from the center, I'll get an even shorter chord. Okay, it's shorter than the previous one. And then if I keep moving away from the center, I'll get a shorter chord and an even shorter chord. And the same thing happens on the other side. As I move away from the center of the circle, I get a shorter and shorter and shorter chord. Okay? This happens on a slant too. So it just doesn't have to be vertical. Let's say I have my diameter, my largest chord goes like that. Well, if I keep moving away from the center of the circle, making a chord, a chord, a chord, all those chords are smaller than the previous one because as I go further and further away from the circle, the chord gets smaller. Same thing happens on the other side of the circle. As I move further and further away from the chord, further and further away from the center, the chord gets smaller. So as the chord moves away from the center of the circle, what happens to the size of the chord? And so what will happen to the size of the chord gets smaller. Another way to say this is the shorter the distance between a chord and a center and the center of the circle, the larger the chord is. In other words, the closer it is to the center, the larger the chord is. So for example, if I was trying to compare, say, this chord to this chord, actually, let me do a different color on that one. If I was trying to compare the yellow chord to the green chord, the yellow chord is much further away from the center. This distance is much larger than, say, this distance. So the fact that that red distance is further away or bigger than the blue distance makes the yellow chord smaller than the green chord. And so basically, you guys have 3 Regents questions to answer, and I may give you a quick little quiz on this tomorrow.